Hey everyone, we've seen a lot of ways now to manipulate geometry and change attributes and all that with Vex, but we haven't talked about yet how to generate geometry from scratch. And we want to start with a simple technique of adding points, but for this we need to understand two things first. So, of course, we use a point wrangle for this, and the command that we want to use is actually Addpoint. And it's relatively easy to understand. There are multiple ways of using this function when we look into the help. Well, two actually, and that is you can add an already existing point number, which means you copy a point. And the other one is you can create a new point from scratch with a new position. So let's do this. So we create a new point, and the first input is the geo handle, so our current geometry. And we want to create a point at the position 1, 1, 1, so it's not completely in the center. And that is the command for that. You just need the handle and the vector that defines the position of the new point. Now, if I do this and look through the result, I actually don't get anything. Why is that? The command doesn't seem to work. Well, the command is actually correct, but the problem here is we have a simple point wrangle not connected to anything. And by default, this is set to points, which means it runs over every point that comes in as an input. But we don't have any points here. So what we have to do is whenever you create something from scratch, be careful to switch this to detail. And this is why it says only once in the beginning, because a detail basically always exists, but a detail also only exists once for anything, which means this is a way of running this command here that is in my Vex parameter exactly one time. Whoops. There you go. And this means now it works. We have exactly 1 point. Now, of course, we can create more than 1 point. Let's just copy that line and create another one next to it, and then another one next to that, and maybe another one next to that, and they go up. That would look like this. We now have created 4 points with 4 commands or functions, so this seems to work just fine. Now, the problem is I don't want to write down this for 100 points I might want to create. And this is why, in my opinion, it's important. You can't really teach Addpoint without showing a very important function, and that is the for loop. The for loop, if you've ever worked with any other programming language, you might already know that it really just runs something multiple times. We already know a for loop, and that is on the sub level. And the speciality here is that it usually runs over something. So it runs for multiple objects, or it runs for multiple phases or whatever. But a for loop in programming is usually made to run something multiple times. So it's not about running for a certain amount of elements, but a certain number of times. So the way a for loop works, and let's see if we can get a help for this in Vex. And unfortunately we can't. But if you Google for it, you will actually find how this works, because a for loop has 3 inputs. And that's the same actually for any programming language for using a classical for loop. There are different for loops, but a classical for loop looks like this. You have a variable that is internally defined as the counter. This is why you usually use C for that, and it's usually an integer. And the first thing you set it to is the starting number. And then you separate this with the next part of the input, and that is how long should my for loop run. For example, as long as C is smaller than 10, so my counter, and then another semicolon allows you to add what happens with my counter for every loop. So in this case, I want to increase my counter by 1. And this whole thing then gets a block and something happens here. So let's run over this again. What you can see is we need an internal counter that counts for us, and that also allows us to later read out where the current counting is. And this is why you start in the first part of a 3-element input for the for with a starting number. And it starts with 0, and with an int you initialize this variable. Then you say, okay, for how long is my for loop supposed to run? And this is, in this case, as long as C is smaller than 10, this will keep running. And with every run, the C number, the counter, and this is why it exists, will be increased by 1. Now you might wonder, why is this so complicated? Well, because this way you can, set all kinds of different conditions. For example, you could start at 5, or you could say, count down please, not up. So this would be a minus equal. Or you can say as long as c is higher than 0, it should run. So in this case, we would count down from 5 to 0. So this is why you have so many elements, because you can create all kinds of specific conditions. But we start with a very simple one, and that is just count to 10. And this means we start with 0, we count until we are higher or equal to 10, because we start at 0 means 10 times. And for every run, we increase the counter by 1. And currently, actually, this happens, but in those 10 runs, nothing happens so far. So let's add our add point. And here we could say, okay, we create a set. And now we could do the following. We create 10 times a point at 0, 0, 0. This would actually work. They're all on top of each other, but if we look what comes out of it, we can see it actually creates 10 different points, all at 0. But you might already guess what we can do now. We can now replace any of the numbers, or all of them, with the counter that we have of our for loop. And this means the first one will have a 0 here, the second point that is run will have a 1 here, and so on. And then it looks like this. We can, in just more or less 2 or 3 lines, create 10 points. And now not just 10 points, but we can actually create 100 points. There you go. And you could theoretically change the distance between the points by changing this number, but then you would have to adjust the map maximum here. What I would recommend is just use the counter as a multiplier, and then, for example, add here the distance between the points, maybe 0.1 as a multiplier. And then you can see now we have 100 points, each with a distance of 0.1 in x. And we can copy this. And we can change this even for x and just add c here. And then you can see we have points that are moving in x and in y actually. And let's lower the amount for x as well. There you go. And this way, and this is why the for loop is so important. We can create, as many points as we want, and each of them still gets a different position in space. So what else can we do with this? Well, first of all, let's actually add this the functions to parameters. So we call this maybe distance in x, and this one maybe distance in y. There we go. And now we can control the distance in x and the distance in y with the controller. And here you see why this is cool. Now we can really quickly change the distance of my points. And of course, we can also change the number of points. I would be careful to use an integer here explicitly. So let's call this num. And now I can even define how many points I want, like this. Oh, that's a lot, maybe 100. And again, I can still change the numbers of x and y. Okay, this is kind of cool, but let's do something more interesting. And this is, we could combine this with our sine wave that we already learned. So for example, we could say that the y element here should not be, just a multiplier of the counter, but we just use a sine wave, and the input of this is the counter. And this would look like this. So the problem here now is that basically our points are too, changing too quickly because the c is an integer. So maybe what we could do instead is let's use our x here and let's save this in a separate variable, for example. So float x should be what we calculated. And now the advantage of putting x in here is that the sine wave is dependent on the x that we calculated. I hope this makes sense. So this one depends now on what this is. And this means when I increase the distance of x, I can, I get a sine result based on the position in x. So I can extend here my wave. And then maybe let's multiply this with something. So this, for example, would be the frequency if we multiply it with something. And at the end, if we multiply it, we get the amplitude. We talked about this in the sine wave video. And then here we can increase the frequency and the amplitude. And this allows us now to change the frequency of our sine wave here and also the amplitude or height. And this is cool because now we can change the number of points of my sine wave. We can change the distance between them, and we can change what frequency or amplitude the sine wave should create. And this is why Addpoint is often used in combination with a for loop. Let's lower the number of points for a second, maybe to 100, because there's something missing here. And that is, of course, let's actually increase the frequency and the distance between x. So something like this, I think, is good. Yeah. So what we can see here, it's only points that we created so far. Now in the next video, we will see how we can connect those points with vex. But before we do this, I want to make clear that very often that's not even necessary. Because the good thing about this approach is that each point has its own number in order anyway, because when it was created, you know, it gets one more point number than the last one. And that means we don't necessarily have to connect them in the vex code directly. We can just use an add function with a polygons by group built in that simply connects our points for us. So you don't always have to solve every problem in vex. You can, of course, combine vex with all the functions you already have. And this way now, let's actually make this red or something so we can see it better. There you go. We can now here create our sine wave, and we can again change the distance, we can change the number of points, we can change the frequency, and we can change the amplitude, and then we get a curve out of this. There are many more things we can do with generating points, but this is just, you know, to understand for you how to approach a problem like this and create curves without even knowing how to create curves in vex. One last thing before we finish. Let's go back to a simple example, an Addpoint in the center of the world. In case, and you will see this in the next video, you need this point at some point in your vex code. So if you want to, you know, change its position, or you want to use it as part of a curve or something, and here's my point, by the way, because I set it to detail. This command actually gives back an information, and that is an integer that defines the point number of the point that you just created. So usually what I do is something like int np for new point, and then I can read out this np later on if I need to, if I want to change the point that I just created. All right, so this is how you create points, and we will use this later on in more complex examples, but I hope this is helpful. So thanks very much and see you later. Cheers.